Hey guys, this is Mrs. Lyons. I decided to put together a video that kind of ties everything in together in terms of moles and atoms or molecules and grams, including molar mass. Okay, so part of this is going to be a little bit of review, but then we're going to kind of tie that all up with some new connections. Okay, so we talked in class about the mole. Okay, and what the mole is. Okay, and we defined a mole. Okay, we said that just like you recognize a dozen, if I say to you, I have a dozen of anything, you immediately know, oh yeah, that means you have 12 of them. Okay, if I have a dozen donuts, I have 12 donuts. You also know if I say, I have a pair of them. Okay, you know that a pair is two. Okay, it's just something that you know. As soon as someone says a pair, you're like, oh yeah, that's two. I want you to think about that, the mole, just like that. Okay, so I want this number I want you to connect this number with the word mole. Okay, 1 mole is 6.02 times 10 to the 23rd, and we're just going to say particles. Okay, basically a mole is 6.02 times 10 to the 23rd of whatever we're talking about. Okay, that could be atoms, it could be molecules, it could be basketballs. Okay, we said if I had a mole of basketballs and I put them all together, it would make a planet bigger than the Earth. Okay, but then when we talk about atoms and molecules, we can hold a mole of particles in our hand. Okay, but what I want you to think, the minute I say mole, I want you to think, oh yeah, 6.02 times 10 to the 23rd. Okay, just like when I say dozen, 12. Mole, 6.02 times 10 to the 23rd. Okay, so we know that a mole is 6.02 times 10 to the 23rd particles. The other thing we talked about in class is that 1 mole is equal to the molar mass in grams, and we get that molar mass from the periodic table. Okay, we said it's the decimal number. That's also listed as the average atomic mass. Okay, so if I want you to connect this because these are some conversion factors that we can use. If I know that a mole is 6.02 times 10 to the 23rd particles, and I also know that 1 mole is equal to the molar mass, if I combine those two things, like a substitution, I know that 6.02 times 10 to the 23rd particles is equal to the molar mass in grams from the, I'm going to abbreviate, periodic table. Okay. So we have 3 conversion factors here. All right. We know that 1 mole is 6.02 times 10 to the 23rd particles. We know that 1 mole is equal to the molar mass in grams. And if we combine those two ideas, we know that 1 mole is 6.02 times 10 to the 23rd particles. That is equal to the molar mass in grams. All right, so let's apply this to an actual element. All right, so let's use my favorite element. Let's use gold, which is abbreviated AU, which is one of those elements that it's like, why would they name, oh, let's make this gold, let's make this, let's be creative. But why would they, why is gold AU? Okay, and how do you remember that? So here's Mrs. Lyons' humor. What do you do when someone steals your gold? What do you say when someone steals your gold? AU, bring me back my gold. Okay, so hopefully you laughed or at least rolled your eyeballs at my silly joke, but let's use gold as an example. All right. So if I have one mole of gold, okay, what that means is I have 6.02 times 10 to the 23rd gold atoms. All right. We also know if I have 1 mole of gold, if I look at my periodic table, all right, pull out your periodic table. Gold is element number 79. Okay, you see the decimal number under there? The decimal number is 196.97. So 1 mole of gold is equal to 196.97 grams of gold. Okay, and again, here we can substitute. We can say that if we have 6.02 times 10 to the 23rd atoms, that is going to be equal to a mass of 196.97 grams. Okay, so here we have 3 conversion factors for a question or questions about gold and moles. All right. So let's look at some examples. All right. So next slide. So let's try to figure out. We're going to use. I'm going to go back and I'm going to copy this because this is really useful, and I want to. I don't want to have to type it out on my next slide. So I'm going to copy this information that I have. If you're making notes on paper, you can just, put that. I'm going to keep this over here. All right. Remember that what I have here, okay, and this is really the important part of this. What I have here, I have 3 conversion factors right here, 3 equality statements. Okay. So what if I asked you this question? What if I asked you how many moles is 9.8 times 10 to the 24th gold atoms? Right? Again, we're going to set up a truth table. Okay, and I'm going to draw it out here. All right. And this is going to be repetitious, but that's okay. Anytime we have a truth table, we are always going to look at the number in our equation, and that's going to be our given, and that's going to go in this first box. So in my first box, I'm going to have 9.8 times 10 to the 24th gold atoms. Make that a little bit smaller so it actually fits. All right. So we've got 9.8 times 10 to the 24th gold atoms. All right. We're looking for, and it's important to make note of what is it we're looking for. We're looking for moles. All right. So to figure out which conversion factor we are going to use, we have to find a conversion factor that has atoms and moles in it. Okay. So if I look, here we go. 1 mole of AU is equal to 6.02 times 10 to the 23rd AU atoms. All right. So again, the thing that we got to remember, and this is why dimensional analysis is so important, we have to put our conversion factor into our truth table in the correct order, okay? And to figure that out, if we have atoms up here in the upper left, that means we have to have atoms down here so that they'll cancel out. Okay, so that tells me that I have to have 6.02 times 10 to the 23rd AU atoms on the bottom, okay? Which then leaves me with 1 mole of AU on the top, okay? I didn't quite finish out my truth table, but let me do that. Okay, so if we plug this into our calculator, and again, you guys, you've got to practice plugging things into your calculator with scientific notation. This is a perfect example of something that will not give you the right exponent if you don't plug it in right. So I'm going to take 9.8 times 10 to the 24th, and I'm going to divide it by 6.02 times 10 to the 23rd. And what I get for an answer, I get 16.27906. All right. Now, remember, I want to, some videos that I've posted in the past talk about significant figures. We're really not going to look at significant figures this year. But what I want you to do whenever you write a number down is include only 2 places after the decimal. So this would round to 16.28. And that's because the 8 would make that 7 round up. And that is 16.28 moles of gold. That's going to be our answer. All right. So let's try another one. And again, just like I did, I'm going to copy this so that I have it handy. Maybe if you're doing these at home or even at school, maybe you have a piece of paper out and you write these 3 conversion factors at the top so that you can reference them. All right. So what if I asked, let's ask a different thing this time. What if I ask how many grams is 9.6 times 10 to the 23rd gold atoms? So I'm going to draw my truth table. Okay. I'm going to start. I'm going to sound like a broken record eventually. You guys will hear my voice in your sleep saying, I'm going to start with the number, which is the given in the problem. All right, so I'm going to start with 9.6 times 10 to the 23rd AU atoms. Okay. What conversion factor are we going to use? I guess it's important for us to think about that, huh? So I've got atoms. My question is asking me to find grams. Okay, so I need to use the conversion factor that has both atoms and grams in it. Okay, so I'm going to use this conversion factor. Okay, I have to figure out how to put it into my truth table. Okay, something that I've seen some students doing is I've seen, oh, I'm always going to put atoms on top, or oh, it was on top in the last question, so I'm going to put it on top. You can't assume units go in the same place. You have to determine every single math problem that you do. You have to determine what goes on the top and what goes on the bottom. And the way you do that, once again, is by looking at the units. So in this case, I have atoms in the upper left corner. It means I need to have atoms down here. So if I look at my conversion factor, I have 6.02 times 10 to the 23rd. So 6.02 times 10 to the 23rd AU atoms. Okay, that's what's going to go down there. Okay, and then the other part of our conversion factor, so 196.97 grams. So 196.97 grams of AU is going to go on the top. Now, please, when you do this math, okay, this is one of the harder things to plug in. We're going to take our given, so type your given into your calculator first, 9.6 times 10 to the 23rd. Now you're going to multiply the number on the top. So we're going to multiply by 196.97, okay? And then we're going to divide by the number on the bottom. So the bottom number is 6.02 times 10 to the 23rd. If I do that correctly, here's what my calculator spits out at me. It tells me I have 314 point, let's put 104,983. That's what my calculator keeps going. So remember, we want to round to 2 places after the decimal, so 314.10. Okay, we're not going to round up because the 4 is lower than 5, so we don't round. Okay, and then our units, we're always going to look at the units that are up in that box right before the answer. So in this case, grams of AU, right? So there is a second question. We're going to do one more. All right, so let's go to the next slide. Again, I'm just going to copy and paste. Hopefully you guys, what I'm trying to show you, actually I'm not trying to show you, I'm trying to make it easier for myself. But what's going to make it easier for yourself is to have these conversion factors written out, okay? And then decide as you draw your truth table which ones to use, okay? And if you can get this process down, once you figure out how to do this, it's going to be so beneficial, okay? Because we're going to do it in the next unit. So, you know, work at it, practice it, ask questions, set up times to come and get help, okay? But make sure that you understand how to do this. Okay, one more problem. How, not how or now, but how many grams is 1.2 moles of gold, AU. Okay, I'm going to draw my truth table. Whoops. Terrible at straight lines. Okay. I'm going to start with what's given in my problem. So what's given in my problem is 1.2 moles of gold. So let's see, I'm going to put 1.2 moles, I'm going to abbreviate MOL, moles of AU. All right. Now, we got to figure out what goes into our equality statement. What do we use? Okay, we have moles of gold and we have grams of gold. So we need to find the conversion factor. Here we go. 1 mole of gold is equal to 196.97 grams. Okay, so to determine what goes in the top, what goes in the bottom, we look at our units. So what's given is moles of AU, which means moles of AU needs to go down here. So 1 mole of AU. Okay. And then what's going to go on top is our grams. So 196.97 grams of AU. Okay. So we're going to multiply on my calculator. We're going to do 1.2 times 196.97. And here's the number that I get. I get 236.364, which I'm going to round to 2 places after the decimal. So 0.36 units. Remember what my units are. My units are grams of AU. Okay, now I want to point something out to you guys, okay? And it's just, I always want you to think about units, okay? But there's kind of this check that you can do. Okay, and I'm going to jump back through the slides that we just did and we worked on problems, okay? And I want you to notice, okay? I want you to notice that wherever I had the unit of moles, okay? So wherever in my question I had moles, notice that the number, what we're going to see, the number's 1 here. Okay, so I put moles. Let's see, that one didn't have moles. Whoops. What did I do? There we go. Here I've got moles. Look at that. The number is 1. All right. So if you like to look at patterns, anytime we put moles into our truth table, the number that goes with it is 1. All right, let's look at something else. All right, anytime we put atoms into our truth table, okay, so here we use atoms. The number here, 6.02 times 10 to the 23rd. This second prob, I'm always 1 off. Whoops, what did I do? Sorry, guys. All right, if you look, anytime I have atoms in my problem, the number is 6.02 times 10 to the 23rd. So let's just make a couple of observations. All right, and these I'm making the point just so that you, because I know some of you are like, oh, so atoms always goes on top. That we cannot say. But what we can say is anytime moles is used in a conversion factor, the number that goes with moles is always 1. Okay. So when you are plugging moles into your truth table, it's always going to be 1 mole. Right? Anytime, atoms or molecules is used in a conversion factor, the number that goes with is always Avogadro's number, 6.02 times 10 to the 23rd. Whoops. All right. So these are the kind of statements that you can say, oh, this is always true. You can't say this always goes on the top of a conversion factor or this always goes on the bottom. But what you can say is, if we have moles in our conversion factor, the number that goes with it is always 1. If we have atoms or molecules in a conversion factor, the number that goes with it is 6.02 times 10 to the 23rd atoms. And think about that, okay? Remember, if we have 6.02 times 10 to the 23rd of anything, it's going to be huge, okay? But when we're talking atoms and molecules, because they're so small, we can have 6.02 times 10 to the 23rd. All right. So guys, I hope that this, was beneficial for you. I hope this helps you understand. If you are still struggling, set up a time to come and meet with me. Come into class, or set up a time outside of class. Ask questions. All right. All right, guys. Have a great day, and I will see you next time in class.